Hello, I'm Sylvia Knight, Head of Education at the Royal Meteorological Society. In this series of short films, we're covering some of the background information that geography teachers may find useful if they're teaching weather and climate at secondary level. This is linked to the Weather and Climate Teaching Guide with accompanying classroom resources which you can find on our website, MetLink. In this film, I'll be looking at the climate of the UK, building on many of the concepts that we've covered in earlier films. The United Kingdom has a unique climate as an island surrounded by water, influenced by warmer air from the south, colder air from the north, warm ocean currents and the Eurasian landmass. Most of the UK has a temperate oceanic climate according to the Köppen-Geiger classification. It basically means we have warm summers, mild winters and rainfall throughout the year. Some northern upland areas, particularly in the Scottish Highlands, qualify as subpolar oceanic. Here's a sample climate chart for Edinburgh. You can see that the average temperatures vary between about 4 degrees Celsius in the winter to about 14 degrees in the summer. The rainfall is pretty constant between about 60 to 80 millimetres per month. Regionally, UK climate varies because of several factors which we can consider. The prevailing wind direction is one of the most important things controlling local climate variations around the UK. If we think about air masses, the wind direction will largely determine the temperature, humidity and rainfall we experience. The weather associated with the wind direction and therefore the air mass will vary around the country. So for example, a polar or returning polar maritime air mass with northwesterly to west-southwesterly winds will bring rainfall primarily to the west coast of the UK, whereas a polar continental air mass will bring rain or snow primarily to the east coast. The wind direction will also affect things like the orographic enhancement of rainfall, the area in the rain shadow of any mountains and the Föhn effect. This windrose is from Heathrow Airport near London and it shows how often the wind blows from each direction. The longer the bar, the more days the wind came from that direction. You can see that most of the time the wind is blowing from between west and south, returning polar maritime and tropical maritime air. So as we get westerly winds more often, it's the west of Scotland, Northern Ireland, Wales and England that gets most rain through the year, with the east being much drier. In this rainfall map, the blue colours show higher annual rainfall amounts and the brown colours lower amounts, and you can see that the west is wetter than the east. With altitude, air pressure falls by approximately 1.2 hectopascals for every 10 metres of height at around sea level. As the pressure falls, the temperature falls because the rising air expands, doing work by pushing away the surrounding air. As the air does work, it loses energy and cools. So as air rises, the pressure falls and it cools. Because the rising air is cooling, cloud may form which may in turn lead to precipitation. It gets colder by roughly 1 degree Celsius per 100 metres of increased altitude. The UK temperature map shows that the upland areas of the Pennines, the Lake District, Exmoor, Dartmoor, the Welsh Mountains and the Highlands of Scotland all stand out as having colder temperatures. Another factor which influences the local climate is the proximity to the sea. Water has a higher heat capacity than air, meaning that it warms and cools more slowly. Therefore, the seasonal variations in the water temperature around the UK are smaller than the seasonal variations in air temperature. For example, the seasonal variation in water temperature at Liverpool is only 9 degrees Celsius. In the winter, the warmer water will prevent local air temperatures from cooling too much. In the summer, the cooler water will prevent local air temperatures from rising too much. So the closer you are to a large body of water, the smaller the variations in temperature. Even a small lake will have an impact on local microclimates in this way. For an island like the UK, surrounded by water, it means that our climate doesn't vary as much between summer and winter as the climate does in the centre of a large landmass, such as North America or Eurasia. In addition, the North Atlantic Drift, which is part of the Atlantic meridional overturning circulation, brings warmer surface waters to the UK. These in turn influence the temperature of the prevailing westerly winds, raising the temperature locally by around 5 degrees in winter, as well as making the air moisture rich. Locally, land and sea breezes can also have an effect. We'll cover those in a later film. Temperature also falls with distance from the intertropical convergence zone. In the winter, this is more pronounced than in the summer because of the extremely cold temperatures that can be reached in the polar regions. The UK lies between about 50 degrees north in the south of Cornwall to 60 degrees north in the Shetland Islands. So in this temperature map, the annual average temperatures are clearly warmest in the south of the UK and coldest in the north. Urban areas also have an impact on their climate, affecting the temperature, wind patterns, air quality, and even precipitation. An urban heat island is a metropolitan area which is significantly warmer than the surrounding rural areas. The temperature difference is usually larger at night than during the day and is most obvious when skies are clear and winds are weak. One of the main causes of the urban heat islands is the fact that there's little bare earth and vegetation in urban areas. And that means that less energy is used up evaporating water, that less of the sun's energy is reflected, and that more heat is stored by buildings and the ground. The heat generated by heating and cooling, transport and other energy uses also contributes, particularly in winter, as does the complex three-dimensional structure of the urban landscape. In urban areas, tall buildings and a generally rougher land surface have an effect on the flow of air, altering the course of the wind and producing turbulence. Even a simple building can produce a complex airflow pattern. This flow of air can then have an impact on the transport and concentration of pollution, leading to pockets of persistent poor air quality. We'll look at urban climate in more detail in a later film. The number of snow days in the UK is very low, as you can see in this map. For much of England, Wales and Northern Ireland, there are fewer than 10 days a year with snow lying on the ground. And this map in particular is changing rapidly as the global climate warms. Tornadoes are a form of extreme weather found in countries around the world, particularly the USA. Surprisingly, you're more likely to see a tornado in some parts of the British Isles than you are to see one in most of the USA. For comparison, the density of occurrence is 2.2 tornadoes per year per 10,000 square kilometres in England, but only 1.3 per year per 10,000 square kilometres averaged over the whole of the USA. However, if you focus in on Oklahoma, part of Tornado Alley, the figure rises to 3.5. Unlike American tornadoes, British tornadoes are most commonly associated with cold fronts and are smaller, less damaging and shorter lived. British tornadoes don't usually cause fatalities, but minor injuries and damage to property can occur. Between 1980 and 2012, there were on average just over 34 tornadoes reported per year across the British Isles, with large variations from year to year. Most tornadoes occur in England, and particularly near major cities such as London, Reading, Ipswich, Bristol, Birmingham and Manchester. Part of the reason for that uneven apparent distribution could be a population bias, since when there are more people, a tornado is more likely to be observed and reported. In November 2023, a T6 category tornado associated with Storm Ciarán caused significant damage in Jersey. And in December of the same year, a T5 category tornado also caused damage in Stalybridge, Greater Manchester. There are many useful sources of data and information for UK climate, some of which we've given in the text below. In the next film, we'll be looking at how the climate of the UK is changing.